Hi there. In this video I will discuss with you how to find the limits for a function defined by three equations. As in this example here, we said consider f of x defined by these three equations. Each equation has certain domain. For the first one, the domain is x less than or equal to 2. And for the second equation, the domain starts after 2 and still going to 4. The third equation for x greater than 4. And we need to discuss the limit for these three equations when x tends to 2 and when x tends to 4 and finally when x tends to 8. Let us see what we will do to solve this example. First, it's better to know how the equations changed according to the real number line. I consider this as the real number from negative infinity till positive infinity. And there are three parts on this real number. The part will start from negative infinity till number 2, which is defined by the equation 1. The first equation of the function defined during this interval. And it is also defined at the number 2 itself, because here is less than or equal to 2. So 2 belongs to the same interval of the first equation. The second equation started after 2, that means it's not include 2, after 2, till 4. So it is still going till 4. 4 belongs to this interval for the second equation. While the third equation started after 4. X is greater than 4. Here is 4, so it started after 4 till the positive infinity. This is the third equation. Now when we need to discuss the limit for this function, we have to consider each one, like this one, the first one here, the limit when x tends to 2. You see here there are two ways to discuss the limit at 2. We need to discuss the limit from left of 2, where x approaches 2 from the left, and also when x approaches 2 from right. So we have to deal with the two equations. That means this equation we will use it for limit from the left of 2, and this equation we will deal with it when x approaches to 2 from right. So we have to get limit from left and limit from right. This at number 2. Same thing number 4. When we need to find the limit at x approaches 4, we have to deal with the left of 4 and with the right of 4. That's because the equations they change around 4. Let us start first with number 2. We can see here the limit. To find limit for f of x when x tends to 2 or approaches 2 from the left. I put here negative sign. That's mean to refer to the approaches came from the left, from this side. So I will use this equation. This is the left. So this equation, as it is rational polynomial, we can substitute in it by 2. That means it's the limit. I will write this equation first. The limit when x tends to 2 from left, that means we will use the equation x over x plus 3. And this will give me here, when you put 2 here and 2 here, that means 2 over 2 plus 3, that means 2 over 5. So it is 2 over 5. This the limit from the left of 2. Now we will look for the limit when x approaches 2 from the right. So we write here x approaches 2 from the right. I put here positive sign, that means the right. For f of x, I'll deal with the second function. You see the second function here, which is this function. We used to rewrite the absolute value without using the absolute value symbol. So if I will do that, I will just pick the case where coincide with this interval, this part of the domain. You see this part of the domain, which is after 2 till 4, it refers to the value inside the absolute value is positive. So we can directly just pick this case, and as it is positive, that means we can write it x minus 2 as it is positive. We don't need to change its form. This is already positive, because if you substitute by any number in this interval about x, you will find this value is positive. Okay, so you just take one case, which is positive case. Here with 2 is from right, approaches to 2 from right. Consider approaches to 2 from right. That means all the values of x here is greater than 2. When it's greater than 2, we'll here consider like 2 approaches to 2 from right. When you substitute about 2 minus 2, that means 0. 2 minus 2, that's 0. So compare the two limits now. You found the two limits. The limit from left, it is 2 over 5. The limit from right, it is 0. As they are different, what our conclusion? We say directly there is no limit at 2. So the result we got from this step, we can write it here. Limit for the f of x when x tends to 2 limit for f of x when x tends to 2 is not exist. I mean there is no limit. This result we got it because the two limits value are different. Okay? If the values are equal, then we got any of them and consider it the value of the limit at 2. This for the first thing. We will do again with the case of x approaches to 4. When x approaches to 4. Also the same graph here for the domain, the real number. This is 4. When x tends to 4, also here we have two equations around 4. One from the left, one from the right. So we will discuss again the limit when x approaches to 4 from left, and also when approaches to 4 from right. When it approaches 4 from left, we will take this equation, and when approaches 4 from right, we will take this equation. Here we can write limit when x tends to 4 from left. From left I put, as I said, the negative sign to show you, to mean it is from left. For f of x, so this equation, and as it is go through the values close to 4, that means this value inside the absolute value is positive. So we'll take just the case x minus 2 without absolute value. So that means it is the limit for x tends to 4 from left for x minus 2. Because this is positive, we take this case only of the absolute value. Now, when you make substitution, it will be 4 minus 2, that's mean 4 minus 2, it's mean 2. This is the limit in case of x approaches to 4 from left. Before going to the limit when x approaches to 4 from right, I want to clear for you or explain for you this point. As you know, the absolute value for x minus 2, it will be defined by 3 cases. X minus 2 when x is greater than 2, or 0 when x is equal to 2, or negative x minus 2 when x is less than 2. This is the definition of the absolute value after we eliminate the symbol of absolute value. Here we just got this situation because x approaches to 4. 4 is greater than 2, as you see. That's why we got this and ignored the other two cases. This just explains why we got this one. Okay, now we will find the limit in case x approaches 4 from right. X approaches 4 from right. For f of x, I will get from right here, this the right of 4, we will take this equation. So we will use the equation square root of x plus 1 when x approaches 4 from right. So you can just make substitution about x here, which will be absolute, the square root of 4 plus 1, 4 plus 1, that means square root of 5. Square root of 5, you know, it's more than 2. So this value is different from this value. This value, the limit when x approaches 4 from left, different from this value when x approaches 4 from right. The same result we got, and then we say there is no, so we say there is no limit at 4. There is no limit at 4. So limit f of x when x approaches 4 also not exist. Not exist. NE. NE, I mean not exist. So here again the result we can write limit when x approaches to 4 for f of x not exist. There is no limit. The last part of this example, find the limit when x approaches 8. When x approaches 8, another time we return back to the domain. Here's the domain of the function. We see number 8 lies in the interval, the last interval, this 3 parts here. So 8 here, which lie in this part of the domain. This part only referring to this equation. So we don't need to discuss from right or left, because 8, if we consider 8 here, so at left of 8 the same equation, and right of 8 the same equation. So we don't need to discuss right and left. We just make substitution directly in this equation, and the result, it will be the value of the limit for this value of x. Okay, so we going to discuss the limit from right and left when the equations is changed around the number. But if it's not changed, we don't need to discuss from right and left. We just discuss in one way, as you see here, limit when x tends to 8 is for f of x it is equal limit for the equation square root of x plus 1 when x approaches to 8. And this limit can be found by making this direct substitution about x, which will give me square root of 8 plus 1. That means square root of 9, which means it is a 3. So the limit when x approaches 8 for f of x is equal to 3, and that's it. Okay, just to give you an idea about the shape of the function with these 3 equations here. See, for the first interval we have the equation for the first interval here. First equation for the interval from negative infinity till 2, this from negative infinity till 2, this the graph here for x over x plus 3, this one. And for the second interval of the domain, this function, this equation of the function represented by this part of line between 2 and 4, here 2 and 4. And the last equation, which is from after 4 till infinity, it's here 4, so after 4 to infinity, give me this part of the graph. Just to give you idea about the shape of the graph, it doesn't, you don't need to draw this graph, but I just give you idea about the shape of this graph. Okay, this is the solution for this equation, and if you have any question, you can email me and I will answer you for any something you need to be explained. Okay, hopefully you will help this channel by subscribing to my channel, and I appreciate that. Thank you. See you again. Bye bye.